Dear viewers, welcome to another video in the series of data analysis using Microsoft Excel. As part of this series, we are uploading videos on how we can use Microsoft Excel and Microsoft Data Analysis plugin to do descriptive statistics. In today's video, we are going to understand how we can use Microsoft Excel to perform one of the very important concepts in predictive analytics, which is simple linear regression. Let's get into this video. As I was explaining in the introduction, today's video is all about how can we perform simple linear regression in Microsoft Excel. So in some of my previous videos, I have explained the concept of simple linear regression and also the concept of R-squared value, what is called standard error, and before performing simple linear regression, why we need to check for correlation and how correlation as a concept is an extension of another concept called covariance. So for you to understand about all these concepts, you can please listen to the videos. I will share the link of these videos in my description. So to start with, we need to understand what is central tendency. Then we need to understand what is measure of variance. In measure of variance, what exactly variance is all about. Variance is for one set of variable, and when we are dealing with two pairs of variables, x and y, we need to move to covariance. Covariance only gives you the direction of relationship, whereas correlation gives you strength of relationship. And once we establish correlation, then we proceed to something called equation of straight line. And once we know all this, then only we will be able to understand and appreciate what is called simple linear regression. So for those who are not familiar about these topics that I have listed down, I would request you to kindly listen to the videos that I am going to share in the description before you listen to this video, because this is just executing simple linear regression in Microsoft Excel. Whereas what exactly simple linear regression, if you want to understand the concept, I would request you to listen to the videos. Now once you know what exactly simple linear regression is, now let's understand how we can create a simple linear regression equation using Microsoft Excel. So here I have a pair of x variable and y variable, and similarly we have collected 6 pairs of x and y variable. Now before proceeding to simple linear regression, first I need to know whether these pairs of x and y variable are correlated with each other. So there is a Excel function called correlation, which is nothing but Pearson's correlation coefficient. So if I use correlation formula and if I put a comma and then I select the first set of variable, I select the second set of variable and close this function, I get correlation coefficient. And correlation coefficient generally ranges anywhere between -1 to +1. Closer and closer to -1 indicates strong negative correlation. Closer and closer to +1 indicates strong positive correlation. So the decision making threshold is 0.8. Anything above 0.8 on the positive side indicates strong positive correlation, and anything below -0.8 on the negative side indicates strong negative correlation. So now what we understand is we get a correlation coefficient of 0.94. So this pair of x and y data are positively correlated. And what does correlation means? Correlation is a degree of interdependency between two sets of variables. That means if this x increases, my y will also increase. That is what a strong correlation tells us. However, if I want to know what is the level at which I need to maintain my x so that I can achieve a desired value of y, then I need to have a model, a predictive model, and that model is what we call it as a linear regression line, or in other words, equation of straight line for a pair of x and y data. So in order to get that predictive model, or in other words the linear regression line, I need to select these two sets of data. I click on insert, and here I can click on scatter diagram. So this is called scatter diagram. And those who are not familiar with scatter diagram, I again repeat, I have made a separate video on what is scatter diagram. And here you see how this dot get created. This dot is created for a x value of 1 and y value of 5. You see here x value 1, y value 5. So from x1 you draw a straight line, and from y5 you draw a straight line. So similarly for 6 pairs of data, the dots are getting plotted, and by that way you get this scatter plot. Great. So from this scatter plot, how do we move to a simple linear regression line? So the terminology linear is very important. Linear refers to a straight line. That means throughout the operating range, this x and y behaves in the same way. They behave linearly. That's what we call it as linear relationship. So if they continue to increase for the given set of data, even if the data goes beyond these observed values, when x increases, y will increase. That is called linear relationship. So now what I do, I select these dots and I do a right click. And when I do a right click, I get an option to add a trend line. So I click on add a trend line. So a trend line get plotted here. And for this trend line, I can say display equation on chart, and I can also say display r squared value on chart. Now, what is this display equation on line, equation on chart? It displays the linear equation, or in other words, what's called y equal to mx plus c. Now, how is this line getting plotted? There is a detailed explanation about this. I have shared a separate video. I request the audience to kindly go through the video on what is the logic or how this number or this equation get plotted, right? So there is a concept of slope and there is a concept of intercept. So the slope and intercept need to be calculated, and from there only we will be able to come up with this equation of a straight line. So since we have now reached this equation of straight line, I can take this equation and solve this equation for any given value of x and see what will be my value of y. Or other way, I can enter the desired value of y and then solve the equation to know what is the level at which I need to maintain my x. As I told in my simple linear regression equation, I have clearly explained this concept. So please go through that video if you have some doubts. And what is r square means? R square is nothing but square of what you have calculated as your correlation coefficient. Here we have the correlation value. So if I square this correlation value, if I say square is nothing but multiplying it again. So when you square this correlation value, what you get is called r square value. And what does r square means? R square means how much of the variation in this predictive model is explained by your inputs. That is what we mean by r square. In a very simple layman language, we can understand r square is always between 0 to 1. And if your r square is getting closer and closer to 1, the distance between your expected value and your observed value. So what you see here as a dot is observed value, and what you see on the line is the expected value. So this distance will get shorter and shorter, and you will be able to predict with much more confidence. That's what this r squared value is all about, right? Okay, so there is one more thing called standard error, but this particular method of graphical representation does not allow us to calculate standard error directly. So then if you want to know the standard error, you need to calculate standard error using the formula, which involve 2-3 more steps. I have explained clearly about how to do that in my standard error video. However, if you have added something called data analysis plugin, as you see here, when I click on data, here you see data analysis plugin. So how to add this data analysis plugin into your Microsoft Excel? It does not come in default, but we can definitely add it from the list of plugins. How to do that, I have clearly explained in the first video of this playlist. Those who do not have data analysis plugin, kindly listen to the video where I have explained how to add this data analysis plugin. Now, if you have data analysis plugin, then what you can do is you can use this data analysis plugin to perform the same regression, and that will give you even more details than what you get from this normal graphical representation. So now what I do, I click on data analysis, I select regression, and then I click OK. So whatever data I already have, let me remove those data. So I'm removing all this data. Now I select my X. First I select my Y variable. So here is my Y variable. So my Y variable is selected. Then I select my X variable. So here is my X variable. I select this X variable. And finally I need to select my output range, where I want to have my output data to get displayed. So I'm going to select my output range in column O. So I am clicking on column O. So this will be my output range. And again, your data analysis plugin gives you 3 options. You want to have the output to be saved in the same sheet, or you want it in a new sheet, or you want it in a new workbook altogether. So I want it in the same sheet, so I select this as my output storage location. And here you have a lot of things to get selected. To start with, I don't want you to get confused by selecting too many options. So I want you to select only a linear fit plot, right? A line fit plot. What is a line fit plot? I will explain. So at this point of time, I want you to select only this option. Now if you click OK, sorry, I think the input range has to be selected properly. My apologies. The input range is from your column C2. It is column C4 to column C9. Output is at O3. Now if I click OK, sorry friends, let me select it one more time. So my y range will be column C to column C9, and my x range will be column B4 to B9. Now if I click OK, I get my regression equation. I also get my other values. To start with, I don't want you to get confused with too many things. So let's remove these values. Yes, these values are also important, but at this point of time, let's stick to some basics of regression. So I don't want you to get intimidated with too much of statistics, too much of calculations, so that we get confused. I don't want that to happen. So what we will now do is, here is our regression plot. So let's understand the basics of regression using this regression plot, right? So let me make it a little bit bigger, right? Okay. So now what is this value? So let's bring everything in one single slide so that it becomes easy for us to visualize that, right? So if you see the calculations that got published, the table that got published through data analysis, here you will see your R value, which we got from calculation, the function, the correlation coefficient. Then you got your then you have your R square value, which we got through squaring your R, or your graphical representation also gives you the R square value. Then you have something called adjusted R square. That adjusted R square is not relevant when you are dealing with a simple linear regression. There is one x controlling one y. The adjusted R square is not a relevant value. Only when you are dealing with multiple x's, adjusted R square becomes relevant. So at this point of time, adjusted R square is not relevant. Then you have something called standard error. And what is the standard error? If you try to predict a value of y through this model, how much error that value of y can have, that is explained through the R square value. So sorry, that is explained through your standard error value. So how the standard error will be calculated? It will be basically calculated based on the residual. That is the difference between the observed value of 7 and similarly the expected value. If I want to make it easy for you to understand, instead of having observation 1, 2, 3, I can just copy and paste this value here so that it becomes easy for you to understand. So let me copy and paste this value, right? So this is observed value of 7, this is expected value of 7, and this difference is what you call it as the residual. So once you have this residual, what we need to do is the sum of squares of residual divided by n minus 2 is your R square value. So the formula, how does it work? I have clearly explained in the separate video on R square, but however here if you want to draw a comparison, then what we can do here is, this is residual, so I make a square of this residual. I make a square of this residual, then I do a summation of this. Now I got the summation. So the standard error formula, so here you have the standard error value, so the standard error formula goes like this. So this is nothing but is equal to square root of this value divided by n minus 2. And what is n here? N refers to the number of data points. So here the number of observations are 6. 6 minus 2. So I close brackets and then I hit enter. So it's square root. I've selected the wrong formula. So square root of n minus 2. And what you get here? You get 1.714, and exactly the same 1.714 is what you got. So if you want to understand this in a very simple way, here you see the blue color dot as your observed value and red color dot is your expected value. So if you select the blue color dot and try to fit a trend line, the trend line will fall exactly on your red color dot. The meaning is, there is a gap between your observed value and your expected value. That means your model will not be accurately predict what's going to be your y value, but it can predict with some amount of residual, that is nothing but with some amount of error. So what will be that standardized error is what we have calculated here. So friends, I hope this video was useful for you to perform simple linear regression. Again, I repeat, perform simple linear regression using Microsoft Excel graphical representation as well as Microsoft Excel data analysis plugin. But the understanding of the concept, what is simple linear regression, as I requested, kindly listen to step-by-step videos that I have given in the description of this video also, which is what is measure of central tendency, what is measure of variance, what is called covariance, what is called correlation, what is called equation of straight line, then understand what is simple linear regression, then understand what is R squared value, and then finally understand what is standard error. So each of this conceptual explanation, I will give the video in the description. Finally, when you know all this, if you want to perform simple linear regression in Excel, this is how you do it. I hope this video was useful. So for more videos on data analysis using Microsoft Excel, kindly subscribe to our channel and support us. Thank you for your time. See you in another video.